Okay peeps, how are you? It's Jay. I want to go through this photograph real quick of the Atlantic Intracoastal Waterway at Wrightsville Beach, North Carolina. I took the photo from the US 76 drawbridge over the Intracoastal Waterway of this marina. Why? Because I like those blue lights that go down the docks and the slips at nighttime. Okay, it's a nighttime photo. That means by default all of our exposures are going to have to be longer to get more light, which means you're going to need a tripod and you're probably going to need a cable release with a locking switch. Okay, I'll get to that momentarily. I've got to break these videos up into little pieces so I don't sew them all together. Now, a lot of people are surprised to hear that this is actually an HDR. What does HDR mean for those of you that are not in the know? HDRI stands for High Dynamic Range Image. Okay, why do we use it? We use it because a lot of times when we take a photograph, since the camera can only see one exposure value per photograph, okay, it's set across the entire photograph. There are areas that are too dark or areas that are too light, okay, and what we want to do is we want to articulate that histogram a little bit more so that we can add more dynamic range, it's called, to the tonal values. Okay, and we can kind of break up those darker areas, break up those smaller areas, so that we can adjust them accordingly to show these areas much more clearly, much more like the human eye sees. Okay, really quickly, a great example of what I use for the human eye and seeing this stuff is when you walk up to an automobile and it's a bright sunny day. Okay, you've got this, and you look down the side of this thing. Underneath the wheel well, it's pitch black. Okay, the side of the car, the hood, the roof might all be nice and exposed well. You could see the color and the gradients and all that, and the shine on the gloss finish. But there might be somewhere on the windshield that has a reflecting sun, and it's just white. It's just exploding with so much, light and color and brightness and all that it looks white. But the human eye connected to the brain can make these adjustments on the fly and kind of fill in data gaps that you know what a wheel well looks like. Okay, so when you look back at the wheel well and you stare at it momentarily, your brain can start to piece together what it looks like, and through the control of your eye, to let more light in right when you're looking at that wheel well. If you quickly look at the bright spot that's shining off the windshield, well, you might get blinded for a fraction of a second, but your eye, your pupils will constrict down, and your brain will, basically, let you dim that down so that you can see the windshield a lot clearer. It's the same thing we're doing here. How do we do it? We're going to get into that in a moment here, okay? Okay, so looking at this scene, what we have here is these vast regions of dark where it's it's nighttime, it's dark out, and we've got some of these trees back here along the coastlines and the shorelines. They're just black. The sky is lit up from some light pollution from Wilmington, North Carolina, which is about 8 miles into the page here. And we have this dark water, and there's some orange being cast by an overhead halogen street lamp, and you can see some of the orange on this guy. Across the channel here to the right is the other side. There's a marina over there. It's not quite as complicated as this one, okay, but it's casting a yellow light, and I don't know why, but you can see it on the sides of these boats. Okay, now what I want to do is talk about the two reasons I went HDR on this. If you look at all these boats in here, look at all those boats. There's tons of them in there. They're all in their own little slips, and they got all these antennae and sides and flat roofs and angled sides and a lot of gloss from the fiberglass. I mean, look at this boat here. You got the sides, you got the black, you got the stripe, you got the shiny fairings and the windshields and all that, and you've got a lot of light coming from different areas and a lot of weird surfaces. Okay, two things. With the HDR imaging, I'm using the software, and I know this ahead of time, that the software is going to align the images, all right, and it's going to try to remove a lot of these artifacts that we see when we have scenes where there might be some motion in them. The reason I say that is because for HDRI imaging, HDR imaging, okay, HDR, you have to take a series of photos, 3 or more, or 2 or more, usually 3 or more, okay? And between the individual photographs that you take to do this whole construct with this thing and using the software for digital photography, you might have some motion in there, okay? And what that results in is a lot of these things that are called ghosting effects, or what you'll see is you'll see fringes around things where things moved, or if a person walked by, or like a boat went by here, or a bird flew by. Ghosting effects, how else to describe? You get these weird fringes, you get these visual artifacts where there's been some shift between the two things. So that was the first thing, is I needed to do it this way to align all this stuff. And can you imagine if this part right here, if this was a jigsaw puzzle, how difficult this part would be, especially right in here with all these boats and how complicated it is. So that aligned a lot of this stuff, okay, and it stretches the photograph digitally, and it lines everything up, and it looks at control points and all that. It's part of the algorithm. The second thing is going back to that tonal range, is because of all these sides and different angles on these boats and the light sources. There's also a moon overhead. It's a high noon moon. It's a waning gibbous. This photograph was taken August 18th at 4 a.m. okay, in Wilmington, North Carolina. You can go out to heavens above and back that date out, or Stellarium or something, and figure out where the moon was, all right, if you want to really look that far into it. But that's why I had to use it. I knew how the software worked before I even started pushing a button. So I thought about this, I thought this whole process through, and for the most part it turned out a-okay, okay? So going back to the original image, that's what we look like. Okay, so let's get down to the nitty-gritty here about what I did to take these photos, because I did start indeed at the camera on site, okay? Now, a lot of, or I shouldn't say a lot, but some people that do HDR, I just found this out, are not aware that you can actually load more than 3 photos into Photomatics. I'm sure it's the same with other HDR reduction software, but I use Photomatics. That's the one I bought. Has good reviews. But you can load more than 1, 2, 3. You can load more than 3 in there, okay? And knowing that, what I did was I went to this site and I set up my camera and I got my frame shot all set up nice and good. You know, I wanted these blue lights in the center, this bright blue light to be at the, you know, this, give it a second here. I wanted it to be right up here in this third, in this corner, okay? And the rule of thirds, and then I had a leading line kind of going out here towards this green channel marker, okay? Fine. All right. So what you have to do is you have to go out there with your camera when you're doing nighttime HDR, especially when you have a lot of point lights like this, and you have to know ahead of time that you're going to be taking these in this way that I'm going to describe to you. Set up your camera, get all your settings correct, your frame, get everything good, and then take your first photo at the computed camera light meter perfect value. Okay, it's right down the middle. Okay, in this case the good value for me was this one right here. This is the first one I took. It was f8 at 41 millimeters at ISO 200. I used 200 just to speed things up. I'm sorry. F8. I must have moved something here. Sorry about that. It was f5 at 41 millimeters ISO 200. It was 15 seconds. All right, that was what the light meter said was the perfect exposure. It's really dark though. Okay, that's fine. It's cool. All right, that's what the histogram said though. So a lot of our work has to be done down in here to break this all up, and to be able to adjust this range to make it more like a bell curve in the end. All right. And usually when you're looking on the sensor, if this is representative of the sensor, this histogram, the upper half, upper 2/3 of it generally has a much more built-in discretization, so to speak, a lot more, it's a lot more sensitive to the lighter end than it is to the darker end. Okay, it's just something to know. I can explain that some other time. But most of our stuff is down here, definitely packed up against the low end, the low exposure end, so that's where we got to do a lot of work. All right. Then what you want to do is you want to take at you want to use your exposure adjust, your exposure compensation, and you want to go through and you want to take a series of individual photographs. You don't have to set up brackets for this, okay? You don't have to do that. You can just keep it on the tripod, just make sure you don't knock anything, move it around, whatever, make sure everything's locked down and steady. Adjust and take one exposure value difference, plus and minus this middle of the road one, the perfect exposure based on a light meter. Take one exposure value difference down and up. Alright, so shorter exposure and longer exposure. And the rule of thumb here that you should remember is that one exposure value is a factor of 2. If it's faster, it's divided by 2. If it's longer, it's times 2. Alright, so 15 becomes 8. It's actually 7.5, but it's 8. And then 8 becomes 4, and then 2, and then 1. And then when you need to go longer and overexpose, 15 becomes 30, and then 60, and then 120 seconds. Okay? Okay, so let me just go through really